Welcome everyone. My name is Vinay Tummarakota, and today I, along with my partner Henry Chin, will be presenting Designing a Graphical User Interface for a Lake Proxy System Model. Before we begin, I would like to thank our faculty mentor, Dr. Sylvia D., for her guidance and feedback throughout the research process. I'd also like to thank the Rice Undergraduate Research Symposium for presenting this opportunity for us to share our research with others and receive feedback. Thank you. Paleoclimate lake archives provide thorough records of past climate change, such as temperature and precipitation patterns of the past. These archives also allow climate scientists to contextualize current and future rates of climate change because they enable climate scientists to test the performance of global climate models. However, the predictions produced by climate models don't always map neatly to data collected from paleoclimate archives. For this reason, in 2015, a suite of Python-based models was created to allow climate modelers to collaborate more fluidly with paleoclimate geochemists, enabling data model comparison between archives of past climate and model simulations. This suite of models was then packaged into a graphical user interface, or GUI, providing a user-friendly interface through which climate scientists could interact with the suite of models. We expand on this work by developing a Python GUI that runs a lake sediment proxy system model, as well as a number of models which reconstruct various forms of lake archive data. The graphical user interface, or GUI, serves four primary purposes. First, it implements a lake environment model as described by Hostetler and Bartlein 1990. The lake model requires 7 input variables which are used to produce a number of metrics, including but not limited to lake surface temperature in degrees Celsius and lake evaporation in millimeters per day. The second function of the GUI is to utilize data produced by the lake model to reconstruct paleoclimate archives, such as hydrogen isotope ratios in epicuticular leaf wax, oxygen isotope levels in carbonates such as gastropods or ostracods, and the presence of GDGTs. For clarification, GDGTs, or glycerol dialkylyl glycerol tetraethers, are chemical compounds produced by archaea and bacteria. When produced by archaea, GDGTs provide a proxy for marine or lacustrine temperatures. However, when produced by bacteria, GDGTs are a proxy for changes in mean annual air temperatures. The third function of the GUI is to simulate sedimentary processes which would modify the measurements produced by the leaf wax, carbonate, and GDGT models. More specifically, any reconstruction of lake model archives must account for the compaction of sediments and bioturbation, which involves the disturbance of sediments due to activity from living organisms. The fourth and final function of the GUI is to incorporate models which assess age uncertainties in sedimentary observations. The GUI fulfills this function through the use of the B-cron model, which simulates plausible age models for climate records.
Now for the methods. We made use of many Python libraries and packages to design, build, and export our graphical user interface. We used tkinter to create and design the actual pages, f2py to run the lake environment Fortran models in a Python context, rpy2 to run the bcron R models in a Python context, matplotlib to create and display graphs using lake model data, and finally pyinstaller to bundle the GUI and all of its dependencies into a single executable that can be distributed, downloaded, and ran. We encountered many roadblocks while implementing these features, especially with pyinstaller behaving differently between Mac and Windows, which forced us to split up and implement pyinstaller individually. In the center of our poster, we have a picture of the main page of our GUI, on which we were able to display text, images, links, and buttons thanks to tkinter. Now for the results. In the end, we successfully built a graphical user interface in Python with 9 pages that can be easily navigated. With the data obtained through the lake environment model output, our GUI is capable of running 7 models: the carbonate, GDGT, leaf wax, observation, bioturbation, and compaction models. We also have 2 pages for plotting the time series and seasonal cycle of the lake surface temperature. If you look along the right side of our poster, you'll see some examples of these models, namely the environment model time series, the bioturbation model, and the observation model. Features of each page include uploading input files, filling in input parameters, running the model and plotting the graph, and finally saving the model output data and graph data. Continuing the results, for Windows, we successfully compressed the GUI and all of its dependencies into a single executable, while for Mac, we were able to compress the GUI into an executable, but the user is still required to download the dependencies alongside the GUI. Finally, we have written documentation detailing installation and usage instructions, as well as a video tutorial on our website, prism-gui.rice.edu.